That's why this whole thing is only a recap of what we have already done. We have not started anything new so that people who join late do not lose. I'm just giving some breathing time for all of you. So I think now maybe it is good enough, about 28. So rest of the people, I don't know. Like, okay, so recording also has started, sharing is there, everything is there right now. Then if you come back to this is the actual code. But we are not like, what is the purpose of this? Our ultimate goal is to like, right here. When you compile it, like, when you compile this particular thing, gcc space my cp.c minus o, keyboard has a little problem. So there is an option in like what it is in the Linux platform on GCC about how to compile this. So GCC is a compiler command. mycp.c your file name. Minus O, that means output. Minus is a switch here. It is an option that you are telling to GCC that don't store the executable code into a dot out, but store that into my file, whatever file name that I am going to give. Output, O stands for output, minus O, output. Output is onto the same file name, like normally you give it as my CP itself, right? You give the same, like that is the normal convention. Whatever is the file name with which you start, you're likely to do it in this particular fashion. Now the executable code is available in mycp. So you can run that by using /mycp, mycp, followed by the arguments. Our idea is actually to give whatever is the source file name that you want to give it, and then followed by the destination file name. This is the idea ultimately. But right now it is not actually opening the files and all that. So our idea is to ultimately copy the contents of the file source to the destination by using the system calls. By using the system calls. So we will modify now. So for all that, like what do we require? We should know about how to open a file and like so the signature for your open system call is going to be the following, as you can see. We can even give man followed by open and all that. So it's giving open VT. We have not asked for that open VT. I don't know like what is actually giving. No. Right. So this is the actual thing what we are looking for, the signature of that and so on. As you can see, uh, the header files that one has to include in order to do this and all that is the following. So one is systypes.h, system types, that's what you mean by. The other one is system start, and then fcntl.h. In order to work on these system calls, you need to include the header files. These are the header files. So what is the signature of this open system call here? If you see, one is int it returns an integer value. Open is the system call name, and the first parameter is the const char star path name. Char star means it should be a string. The first one must be the file name that you would like to open it. And then the second one must be flags, integer flags, because you can open the file either in a read mode in order to read the contents, or in a write mode if you want to write onto the file. So you can open the file for reading purpose, for writing purpose, sometimes even for appending to a file, and sometimes even for reading as well as writing. So the flags are there, like 0 means for reading, 1 means writing, 2 means read write, so something like that. So we will see like what flags are and all that. Actually, I think that stands for the mode actually. Sorry, flags is the flags meaning is somewhat different, but mode, what I have just now talked about, is a mode, right? So just consider that mode means opening mode, reading mode, writing mode kind of thing. Flags is actually what is the what you call the permissions, file permissions. What file permissions would you like to have for the for that particular file? That's what actually this flag stands for. Like we can see below, it's going to explain all those things. Open system call opens the file specified by path name. If the specified file doesn't exist, it may optionally create it if required, right? So the return value of open is a file descriptor, a small non-negative integer that is used in subsequent system calls, read, write, lseek, FCNTL, and all that. Whatever is the number that open returns, that number can be used in the other system calls, read, write, lseek, FCNTL, to refer to the file. The file descriptor returned by successful call will be the lowest number and all that he is talking about. Whenever it fails, all the system calls, whenever they fail, they return negative numbers. They return a value less than 0 when they fail. By default, the new file descriptor is set to remain open across exec and all that. So you don't need so much of details here. As you can see here, the argument flags must include one of the following access modes. Oh, okay. So the flags here, flags argument, the argument flags must include one of the following access modes. What are the modes? Flags only actually. Flags only is going to talk about read, write, and all that. So O_RD only means reading purpose. It is a constant value that is available in those header files. Or you can also give directly the 0 kind of thing for reading purpose. So let us use the corresponding constants only. That's a good practice actually. O_RD only for reading purpose. O_WR only for writing purpose. O_RDWR is read write mode. These request opening the file read only, write only, and read write respectively. In addition, 0 or more file creation flags and file status flags can be bitwise odd in flags. Right? So if you want, we can also create a file and all that. The file creation flags are O_CLO exec or O_create, O_directory, O_exclusive, like this. So there are a number of other kind of things. So these things can be odd if in case you want to. The file status flags are all of the remaining flags listed below. The distinction between these two groups of flags is that the file creation flags affect the semantics of the open operation itself, while the file status flags affect the semantics of subsequent IO operations. The full list of file creation flags are the following. O_append also is there if we want. So whenever you are about to write something, you can append to the existing file. Because if you open a file in create mode, it is going to overwrite. The entire thing will be lost. Whereas you want to append, you can also append to the existing file. O_async, O_close. So much detail is not required, but minimum knowledge is required so that you know what a system call is and all that. So OCreate is used in order to create a new file. If path doesn't exist, create it as a regular file. The owner of the new file is set to the effective user ID of the process and all that. The mode argument specifies the file mode bits to be applied when a new file is created. Mode argument. If whenever you specify, this argument must be supplied when OCreate or OTemp file is specified in the flags. If neither OCreate nor OTemp is specified, then mode is ignored, as you can see. So only when you are about to create a file, so what is the permissions for that particular file you require can be indicated by the mode argument, the third parameter. Right? So because we also require now. So when you want to write a file, then we need to create a file first to begin with. You have to create the file and then write it. So when you are creating, you need to use the third parameter also. And the third parameter, like what it is, like what are the permissions you require as a part of it. The effective mode is modified by the process umask in this thing. In the absence of all that, he is talking about several other details. Anyhow, the following symbolic constants are provided for mode purpose. Again, constants are provided here. So when you give a constant like this, user has read, write, and execute permissions. So user only has read, write, and execute permission. So user has read, and others also want and all that, you can always specify. So basically we are going to copy a file. So user must have read and write permission. So we can say read and write means 600. As you can see, read permission is 4 and write permission is 2. So write permission is 2. So read and write, in case you want, you need to add these two actually. 600. Read and write. So SI, or we can also use the constants whenever we require, according to POSIX standards and all that he is talking about. I think this much knowledge is good enough. We don't require too much of this particular thing. We can go ahead. So the header files that we would like to include are the following. Systypes, Systat, and FCNTL. So these are the header files that we need to include. So let's go back to this particular thing. Okay, so what we would like to include is the following. Sys types, and then system stat. Stat is basically in order to find the file related information, statistics, what is the size of the file, who is the owner of that kind of stuff. FCNTL.h. File control, it stands for. File control.h. These are the header files that we would like to include. In fact, we can skip the ones, but I'm just trying to tell you about the importance of the header files and the usage of the system calls. Now that we will print all those things, but apart from that, the other things we'll have to do it. Now, like what are the variables that we require? Let us actually take a look into that. We require one variable in order to hold the reading of the file. like whatever is the source file that you are reading. So that, but to catch that, we require, let us say, RD. RD is a file descriptor for reading purpose. Similarly, WR for file descriptor for writing purpose. So these two we require. And then any kind of return value that you are actually getting, we'd like to take a look into RV, because every system call, after making a call, it returns a value, and that we can examine whether it is successful or not. And that we would like to use it for by using the RV, return variable or return value, whatever. And then, because whenever you are trying to read from a file, probably you want to read an array of characters. An array of characters. So for that, you need to specify a buffer here. You need to specify a buffer. So that you can say char followed by how many characters at a time you want to read from the file. That you can specify. So let us say buffer of this is the name that you are choosing. The number of characters that you would like to read at a time. Probably some 10 characters, right, at a time. So what are you going to do it? You will open a file for reading purpose. You will open another file for writing purpose. And from whatever that you have opened for reading purpose, from that file you will read. So about some 10 characters. After reading this many number of characters, you want to, whatever that you have read, you would like to write them onto the other file. Right? All that. It's going to happen in a iterative manner. So now let us actually start writing the actual code. Now the first thing that you have to do is to open the file for reading purpose. So you say RD is equal to open the file, open of the file name. So file name is coming from the command line argument. Your AV of 0 is the command itself, and AV of 1 will be the first argument, which is the source file name. So AV of 1. AV of 1. This is the one. And the other one, now you'll have to specify O underscore. O underscore is not coming. I'm just looking for the underscore character. Okay, so it is how it is working. O underscore RD only. This is a constant that is declared in the systripes.h, and you are directly using it. Or you can also use 0 also, in fact. 0 means O underscore RD only. 1 means O underscore WR only. Like that. Anyhow, so you want to open this for reading purpose. So nothing else. Semicolon. And in case RD is if it has failed, you'll have to take some of this thing. Normal practice is you'll have to use immediately after that if RD is less than 0 for any reason. If it is less than 0 means it has failed to open the file. So in such a case, you have to give some what you call some error message to the end user and exit the program. So you'll have to specify now printf followed by cannot open the file, right? It cannot open the file. C means again I cannot. I don't have that. We can directly specify percentage, yes, cannot open this, and then a new line. So what is the file name? The file name that we try to open is AV of 1. AV of. For some reason you have failed. And then terminate the program. You can terminate the program by just simply exiting this. Now you are terminating because you are failing. So you exit with anything other than 0. Exit with 0 means it is a normal terminate. Exit with non-zero means it is an abnormal terminate. So that is a good habit by exiting with this thing. So like this. Now that you come to this means that opening is successful. Similarly, you have to open the file for writing purpose. So you say WR is equal to open of. So what is to be opened? The second second parameter will give you the file name to be opened for writing purpose. Writing purpose. Open of area of 2. And this now, because you have to create a file. You have to create a file also. So you have to specify here open of this particular thing. AV of 2, comma. And then what is the mode? The mode is O underscore. Again. Write only. W or only is one thing. But apart from that, we also must create a file. So you have to use bitwise OR operator for that. You want this as well as that and so on. That means you have to specify the bitwise OR operator of that particular thing. So you say O underscore. Create. Create. So this is what we would like to have. The third one, if we want, we can. Otherwise, we can also ignore it, in fact. But for the time being, let me just only pass on these two parameters. And in case it fails to create a file, again you will get an error message. So for that again, let us have this particular code. So here instead of RD now, it's going to be the file descriptor WR. And here the message is likely to be, it cannot create the file basically. It is failing in creating the file. Cannot create so and so file. And the argument is going to be here. What is the file that you are trying to create is AV of 2. Right? And then exit with a different this thing. So that means whenever the program exits with 1, we understand that, oh, it has failed to read the file. Exit with 2, it has failed to create the file. So that kind of stuff. That is how the return values are going to be useful. So now that you come to this particular level, you have both reading and writing. Let me see whether any of the students are waiting. Okay. Right. So we have both the reading file descriptor and writing file descriptor. Now you should continuously read and write until all the characters from the source file are actually written to. That's the idea. So we can now have a kind of an infinite loop kind of it. So we'll say while. How do you have an infinite loop? While 1, right? So this is a kind of infinite loop. Internally, we'll identify what is the condition where this infinite loop is going to break. We'll see that. So the first thing is you have to now read the characters. Read the characters. So in fact, how many characters are read? For that also you can have one more variable if we want. We can use in fact RV also, but nowhere we are using RV, depending upon the situation we are using. So instead of this, now let me call this as number of characters that are actually read or written to, whatever. So let me use NC, stands for number of characters that are actually going to be read. Now, so here we say NC is equal to the read system call returns actually the number of actual characters that are actually read. So we'll say read. Read is a system call now. Read off. To this, what is the first parameter? Whatever is the file descriptor that is already opened. Now you want to read from the read source file. So RD. So RD means whatever is the file associated with that particular open system call. From that file you are actually reading. Where do you want to read? You have to supply a buffer. So you specify buff. You specify the buffer. So already you have the enough this thing. And after this now, you have to specify how many characters you want to read. Your intention. It's not that it's going to be fulfilled, but your intention. Like normally you specify the size of the buffer. So we have specified like a buffer to be 10 characters there. Here also you can specify 10 like this. So you are indicating that you want to read 10 characters. That many may be there in the file or may not be there. That's why the read system call returns. So if it reads only 5 characters, then it returns 5. So that 5 is available in NC. Then you know that many characters are to be written at the time of writing. So here, if by any chance now, if the number of characters returned is less than or equal to 0, that means there is nothing. It's over now. So everything is over there. Like so here, if here NC is less than or equal to 0. Either it is less than 0 means it has failed to read. There is some error actually. 0 means it returns 0 when no more characters are available. That means it has reached the end of the file. The read system call returns 0 when it reaches the end of the file. Whereas it returns negative number if it fails to read for some reason. So both we are addressing in a similar manner here for the time being. So whenever that is the case, what is to be done? Everything is over now. If NC is less than or equal to 0, everything is over. So you say break. You are breaking out of the loop. So that means the job is done. So otherwise, NC characters are there. So those things are to be written now. Those things are to be written. In fact, you can again say, that's why probably one better mechanism, uh, this itself is good enough. Okay, so NC again, number of characters written now. So instead of what you call read now, it's going to how many characters are actually written. We will ask it to write many characters maybe. So you say NW equal to, or NC only, sorry. NW, we can have one more variable if we require. Let us see. Write off. Write where you want to write. Write into the file descriptor meant for writing purpose. So you have WR there. And what is the that you would like to write? Whatever is the contents of the buffer. So you specify buffer. Contents of the buffer. Because we have already read. Comma. And how many characters are to be written? Buffer only is starting address. So how many is indicated by read. So that is NC here. Whatever is the number of characters that are returned by your earlier read operation, that many number of this. That's all. So here again you will have to examine whether both should be equal. In fact, you are asking the write system call to write NC characters into the file. Naturally, your return value of write should match with NC. If there is any problem there, you have to report it. So we can say so if NW, if NC is not equal to NW, that's what we mean by NW is not equal to NC. That means there is a problem in writing. Right? So this we should report in fact. So not only break, we should also report it. So no doubt we'll have to break it, but we should also report that there is some problem while writing. So we'll say printf problem while normally you should not get it, but you are actually putting a message here. Problem while writing into so and so file name. What is the file name? File name we will specify percentage. Yeah. The file name we know it. It is AV of 2. After this, you will break it. So we have to break from the while loop. So you say break. So this part is over. After doing this now, you will have to close the while loop. You see now the while loop, if you just pay attention to this, while one forever actually, you are reading 10 characters into the buffer, and then if there is any problem, that means either we reach the end of the file or you reach the some error, so you break it, right? So you have come out of the you have exhausted all the things. There is nothing to write. So, but if there are some characters, you have to first write the corresponding things. And the number of characters that you have asked for and the actual characters that are written, if they don't match, also there is a problem. So you are actually reporting that. Right? So again it goes back. If everything is all right, if this is not matching, that means NW is equal to MC, that means again you go back and read. Read, write several times. So at the end now, what you have to do is, you have to close both the files. You have to close. So you have opened for usage, and after the usage, you have to close close the files. Close on. You have to specify the file descriptor whenever you are closing. So file descriptors are read and write. Only one at a time can be closed. So again close this second one. Writing 8. Right? And then exit the entire program. That's all. It is as simple as this actually. It is a simple program. The lengthy is there because of the error condition. We are trying to take care of the error situation. Otherwise, the length is going to be very small. The actual logic is small. Right? So you have included all the header files required. And then command line arguments to take care of it. The signature of the mail, you have put it like that. And then you have declared all the variables required. Line numbers from 10 to 13 is only just display the parameters there and all that. If we want now, like this is meaningless actually. Like we can probably let me put a comment here. I'm putting a comment. But if we want, we can actually specify like a message saying that we are trying to copy a file. So printf. So here you can say copying, right? It's more like what it is, verbose kind of thing. So you can say copying. Copying what? Copying the file. If we want, copying the file. Which file it is? Some file percentages to another file percentage yes. Copying file x to y. That's it. New line. So what are the things? Parameters are AV of 1 and AV of 2. That's it. So this is a message copying the file so and so to so and so. So and after that you are actually trying to open the file for reading purpose. If the opening fails, exit it. If it is successful, open the second file for writing purpose. But whenever you are opening the second file for writing purpose, you have to open the file for creation. So create. This also you have to specify. Right? And if there is any error here, you take care of it. And the forever loop is going to be like this. Continuously do that. It's very simple mechanism. Now that I'm going to save it and come back to this particular thing. And now you try to compile this thing. So gcc mycp.c -o my like this. So there's some errors here and all that he's talking about. Implicit declaration, close somehow, probably close is available in somewhere else. We'll have to see. Declaration of function, right? Did you mean F right and all that? NW undeclared. NW is okay. NW we are not declared. That we'll have to take care of it. But these things close, close. Did you mean the P close and all that something and all that is talking about? Okay. So this is the way, right? So read RD buff implicit declaration of function read. Did you mean F read and all that? He is actually talking about. Maybe like let us see. Read requires a different what you call. You can see here man followed by read. Read requires actually this is the header file unistd.h. This is the header file. You don't have to remember these things, but when you start using these things and all that, it becomes a habit. But the other things are more important. As in unistd.h, that also requires to be included. Unix standard. That's what you really mean by. paste it. Right. So this is included so that read related error will go, and number of characters written, right? So you are using another variable NW. NW we have not declared. So declare that also to be a part of it. Number of characters written. So that way, if you want, NC can also be NR, in fact, if we want. Number of characters read, if we want. NR. NR and WR and all that is there. So here we say NR here. And here also we say NR. NW and all that. Here while writing, you'll have to specify NR. Okay. And here also, same thing. Right. So this is done. Now you save it. Save that. Go to the other one. And okay. So now you try to compile it. Compile it. Let's see. So the errors are taken care. So whatever. So we have compiled basically, and the entire thing is put into my CP now. Now that how am I going to copy the files? We can say mycp.c itself can be copied into another file, another backup kind of thing. So we can say /mycp, and then what is the file that you would like to copy? If you give a file that is not existing, you should get an error message, right? So wrong file, let us say wrong. You want to copy wrong into right. Let us say. See, copying the file wrong to right cannot open wrong. Right? So that's why it does get out of that. It could not do that. So that's where the error messages will help you actually. Copying the file is the standard message that you will always get that. Now that like you want to copy it, let us give a write file. Probably you want to copy mycp.c itself. mycp.c. Right? So this file, this is the source file you want to copy. And you want to take a backup of this particular thing. So we can say mycp.backup, BAK. Right? Start then enter. So let's say copying the file. So it's done now. How do we know whether it's really done the job or not? The file must naturally be there. So you can, one way is you can give a long listing of this particular thing so that you can see the details. That is one way. It's not the exact thing and all that. But let us see ls minus l, a long listing of mycp. So we can say dot star also, right? All of it. So as you can see here, because we have not specified the mode there, it has created a file with no permissions. All of them are hyphen there and all that. If we want, we'll have to specify the corresponding mode also, so that those permissions also will be there as a part of it. But otherwise, the file size are the same, 716 bytes actually, 716 bytes, both of them. There is another way by which you can compare it, like we don't know, let us see here. By using a command called compare, right? There is a command called CMP to compare two files, whether both of them are same or not. So you can specify mycp dot followed by backup and mycp dot C actually, you will have to specify that. That's fine. So you are comparing these two files, contents of them. And if you see here, It's saying permission denied because as you can see, all of them are hyphens there. All of them are hyphens, indicating that you don't have the permission. Even though you are the owner, still you don't have the permission. So you have to first change those permissions and all that, but you don't have to, like, if you can, you might have already learned in earlier classes, we don't know, like there's something called chmod, right? Change the permissions. 700 or 600 is the right thing, read and write permissions for this particular thing. Give this. Now, if you see the ls-l long listing, you see there read write permission is there. Read write permission is there. So you are actually talking about this particular thing. Read write permission. So earlier it used to be hyphens, meaning that no permission. So now you can actually execute the comparison also. You can compare. So it is silent, meaning that everything is okay. So if there is any error, it's going to tell so and so numbered character in this file is different from so and so character in the other file and all. Now we can also use, in fact, the mode also, so that permission problem should not be there. That also you can indicate here. After doing all this, comma, you want the 600, right? So you specify 600 is octal here, followed by 600. The 0 is important here, in fact. 0 is important. So this is what it is. Let us see what is going to happen here. And you come back to this particular thing. Let me remove the file, backup file, whatever. Remove his backup. Right. So I have removed the file backup so that it won't be there. As you can see, there is the only file that you have. Now that you have to again compile it, recompile the whole thing like this. Compilation is done. Now you have to copy it. So mycp, you have to copy. Right. So this is the one. mycp.c followed by .backup. Copying the file, it has done all that. And now if you see the long listing of this particular thing, you see there read write permission has come. Because you have asked for that 600 you have given there. So at the time of creating the file, you should create the file with reading and writing purpose. So that is the purpose of the third parameter. If you don't give it, all the permissions will be nullified there. So the importance of the third parameter, especially when you are creating, you have to actually use it. And then 723, all that is there. If you want, you can also see here what is there in this particular file, mycp.back. Right, naturally the same file. So you can see it has gone past all that. Right, you can give that. So this is the actual context. Because you are using NL here, number the line. Each line is going to be displayed along with the line number. So that's why you are seeing 1, 2, 3, and so on in that particular fashion. Right? It is as simple as this. So any questions now so far? Are you all following? Is it okay now? Like, did you any questions so far on this particular thing? Otherwise, we can move on to the next topic. Almost operating system is over. Then we may have to come back to the Java once again. Okay, so anyhow, so the recorded video will also be there. This source file, maybe I will share it after some time. Today and tomorrow, I'm not going to share it. It will take some time, but at some point of time before the next session, they will be uploaded into YouTube. Okay, so then like there is hardly any feedback as usual, right? So this is the program for copying a file onto another file by using system calls. System calls like open, read, write, and close. And you need to understand that it is as simple as this. Okay, so now we will move on to the Java part once again. There are some more topics that are left, and we'll have to go into those details. Essentially, today we will just begin with another Java class called file class. There is a class called file in IO. This thing, there is a class called file, especially in java.io package. Java.io package. This contains a file called file class is there. By using this file class, you can either create new files, number one. Not only that, you can use actually a file class to create a directory file, and you want to list all the files present in a directory. This class is going to be very handy. You just simply open the directory name as a file and then ask the object to give the list of the files. It's going to give you that particular entity. Let me just probably open some kind of online things if they are existing. Let me see here. So this is small this thing. If you want, I can share the corresponding thing. So the link I'm just, but it is available in many other places as well. Essentially, you need to understand about how to list the files and folders in another folder. Right? How to list files and folders in another folder. So for that, this link is going to be handy. Let us see what it is going to do. As you can see, the class named file of the java.io package represents a file or directory in the system. This class provides various methods to perform various operations on files and directories. One of the important things is to list. To get the list of all the existing files in the directory, this class provides the files by name list, returns the names, and the list files returns the file object with different variants. There are two methods. One is a list method, the other one is a list files method. So you can see first list method, what it is going to do. The method returns an array of strings, actually, array of file names. The list method returns all the corresponding file names, basically. It's a very simple mechanism. As you can see here, the following Java program. What are you doing here? Import java.io.file. Right? You are importing. And related exception also you are importing. Import java.io.io exception. If you want a little bit. Okay, so this is the actual program, as you can see. Public class name. Any class name you can give, no issue. And then public static void main, all this you are already familiar. Because whenever you are handling IO and all that, most likely some exceptions are likely to come up. So, because you don't want to handle them, you are directly saying main of this throws IO exception. So straight away you are not using try class. Instead of that, you are directly telling this Java JVM that the main method is likely to throw the IO exception. You are not going to handle it. So throws IO exception, no issue. Curly brace begins. And then here file, any file name, some variable name equal to new file of. You specify the directory here. Any directory that is a valid directory within your system. So you are creating a file object for a specific directory. And especially whenever you are handling, you want a reverse slash, because in the Windows environment, reverse slash is the delimiter between the directory names. Whereas reverse slash has got a special meaning in Java or C language. Because reverse slash n, reverse slash f. So we use that for that purpose. So if you want reverse slash itself as a character, you have to use 2 times. 2 reverse slashes whenever you want one single reverse slash. Right? So this part you should be familiar. Because reverse slash has a special meaning. So you have to use 2 reverse slashes whenever you want a reverse slash to happen as a part of it. So this you should be familiar with. So any name you can specify. And after that, what are you doing? You can see here. String contents followed by an array. Contents is an array here. Is equal to, what are you doing? This particular object now, file object, directory path dot list. This list is a method that returns list of all the file names. List of all the file names. Whatever file names. So file names that are present within that particular directory. So then like you can just simply display them, right? It's a very simple mechanism. So list of files and directories, and then just run through a loop for I equal to 0, I less than contents not like, because this is an array, contents not like, and simply print. It is such a simple mechanism. But the purpose of this is only to list the file names. But if you want to list the file names along with some other attributes of the file, like even the file size you want to display the file name as well as the file size or the owner of the file. So that kind of additional things. Then you have to actually return the file object. Instead of list of file names, you have to return list of file objects. For that, there is another method called list file. Here, file object you are going to get. File object, the advantage is that you will have other details about each file. So that's where this list files method is going to be helpful. Same mechanism even now. So you import java.io.file, import java.io.io exception. And then public class, any class name. As usual, static void main of all that throws IO exception. Create a file directory. So file, variable name, object name equal to new file of this particular. Now instead of invoking a list, you are invoking list files, because this list files returns array of file objects. So you have to specify here file and then variable name, square bracket begin and end. So this is different now. Instead of file names, you are getting file objects. So that's why you have to declare this as file objects. So you have to specify file here. So this particular object now is returning many more details about each file. And those details will be available in this particular thing. We'll get to know what you are actually talking about. As you can see now, you want to print each one of them for each loop here for file colon file list. So for every file within that particular thing. So the file object here has got many more like methods using which you can get to know all those things. So for example, file get name. You are going to get the actual name of the file. So this you are getting even in the earlier case, but you are going to get some more details. You want to know what is the complete path name of the file. You can get by saying file dot get absolute path. That means complete path right from the root directory. It's going to give you the complete details about that particular path. And then you want to know what is the size of the file. That you can get by using file dot get total space. Get total space is the method on the file object. And then just simply close the whole. So it is a very simple, handy class which is available in java.io.file, and one can actually write all that related stuff. The output you can see here, the final output, list of files and all that. File name is so and so. File path is absolute path, means you are going to get the complete path. And the size of the file is so and so. Again, second one, next one, second file name, and then all that. There is one more like called as list followed by a filter you can pass it on. This is a little advanced one, meaning that you don't want to list all the files, but you want to list those files that match a specific condition. Like you want to list all the C programs, or you want to list all the Java programs, right? So we should be able to do that by applying a filter you can do, or by using a simple comparison of the file name also we can do. But filter is a more like a sophisticated way of handling that. File name filter and all that. This part we will see in the next class as a part of it. But actually let us see how you can actually write the code and all that in our this thing. I will show you the program that I have already written so that we can save time and all that. In a slightly different way, I have written that. Probably we can see here, like what are the corresponding things. Do we have that? List class, right? List.java. So let us display the corresponding thing. List.java. So this is the actual program that I have written, but a little bit more details are there here. We are doing many more things maybe. We can also open this in the editor itself so that you will see all the colors and all that. So this is the one. Okay. Now you can see like what we are doing. So as it is, like you'll have to import the java.io package. So import java.io.star is the file only you are importing everything. And because I want to display all the files within the directory in a sorted manner, in an ascending order of that. Normally, That's what it's going to do it, right? So especially when you see here, whenever you display, you use ls command, it displays all the file names in an ascending order actually, in an alphabetical order of the file names. So that's why here we are also trying to do a similar thing. Otherwise, it's going to give you in a random order there. Most of the times, depending upon the order in which the files are actually created, that kind of stuff you are going to get. So public, like you are trying to import the util class, util package, java.util.start, public class list, public static void main, this all you right. Now file f equal to new file of dot start. So what is it? Like here in Linux platform, you can use this class. In the Windows platform, you have to use a reverse slash because the directory delimiter is different in both the things. So file f equal to new file of this thing. So what it will do, this program will always display the files and directories present in the current directory. So dot means the present working directory. And then string array followed by files. This also you know. So, and after that, because like you can also directly specify, as you can see, like we are not using any try this thing, files equal to f dot list, as you can see. And then these things and all, I think it may be slightly difficult for you straight away at this stage. Sorting and all that. Okay. Let me change all these things. I think so that the way you can understand is better. So this is okay, files equal to all this. And this entire thing we will try to simplify this. I think this itself is good enough. Right. Like this. And this whole part we will remove it. This is not required. Ooh. Okay, so I'm just modifying so that it becomes much easier for you to understand and all that. It's a very simple code that we are actually trying to put it. F dot list is going to give you the list of the files. Now this arrays dot sort. Arrays is a class actually that exists in java.util. Whenever you want to sort anything, you can use directly the built-in sort method. So you are trying to sort like that. So arrays dot sort of, straight away you are specifying files. Files is actually an array of strings anyhow, no issue. So after sorting that, you are specifying for each one, you are trying to print it. So starts with dot and all that, you are actually saying this also is not required. Let me simplify this whole thing. Just simply print. Print the corresponding thing straight away. That's all. So I think all of you can easily understand what's going on here. Now let us go to this thing and try to compile. Try to compile. Compile this. So this is how you can compile it. Now if you want to run it, you specify Java followed by list. because now no command line argument, you are not taking anything. You could have written that way also, but right now it is always going to open the current directory and list the files within that. So naturally, all the files, whatever that we have here, are going to be listed. But it is likely to run very fast, so you will use a pipe symbol and then use the less, so that so one at a time you can actually see. See here, there are so many files that it is actually listing. The files starting with dot and all that, as you can see. Especially in Linux platform, it is going to create several files starting with dot, and that are not going to be displayed when you use ls command. When you use ls minus a, all files, then it's going to display. So these file names you don't see in the actual ls command, right? So there are so many right up to this particular 72.c. So right from here, all these file names, all these files are there in the current directory, starting with dot this thing, dot profile, dot pki, so like that. But these file names are not going to be displayed when you use default ls. And the other files are there anyhow, as usual. So one thing is like if you don't want this way, you want to display one file in separate thing, we can also use in that way also. Here, a new line you can put it and then save it, so that like probably again recompile, you will get one thing into one separate thing. So like this, these are the different files that exist. So there is a dot java, so dot hidden, so and so on, so many, which are not going to be displayed when you use ls command. But when you use ls space minus a, when you use minus a, then you will find all those things also to be there as a part of it. So when you give like this, it may run out of this thing. So you can see now, so all this dot gconf, dot genome, dot all that, they will all come as a part of it. So by default, your Java list is going to return all the files, all the files. It is up to us whether to display all of them or you want to suppress all of them. So that's where we have actually written there. So here, you don't want to display, for example, file name starting with dot. That's where this logic is going to help you. So when you say if, right? If. So what? If string now, yes dot starts with, right? There is a method called starts with in string class. There is a method called starts with in string. And by specifying that, it's going to be true false kind of thing. So if it is starting with a dot, you don't want to display, right? That is our interest. That means it should be negated, right? So yes dot starts with returns true if it is starting with that. So whereas you don't want to display, so you say not this particular thing. If yes, that means if the file name is not starting with dot, then only you display it. Then only you display it. So this particular now modified program will list files similar to that of the default version of ls. So that if any file is starting with a dot, it will not be displayed. It will not be displayed. That is the purpose of this particular. If not, yes dot starts with dot. Now you save it and again go back to this particular thing and compile. You again recompile Java C this particular and run that. Java list followed by this. Now if you see, it is starting straight away with 72.c and other things. So all the dot files are not taken or not going to be displayed here. Whereas several other things are there as a part of that. So all of you are like in sync with the class now. You're able to follow it. Any questions? Following the class? So you try to like write these programs and verify what's going on, and you're able to follow it or not, kind of it. Tomorrow we will see the continue the classes on Java, especially the interfaces, abstract classes, and all other things. I think G. Narasimham also is trying to cover some of those classes. So try to work now. We are fast approaching the second mid also. So if you remain in the same state, it will be very difficult to even the clear the examination if you don't have enough internal marks, right? So with the observation in this first mid, it's very difficult. So try to now fall in line. Any other questions then? If nothing is there, I will just simply close.